let's look at another example of theoretical probability. The names of 9 birds and their food preferences are listed below. Each of the 9 birds' names is listed on a slip of paper, and the 9 slips are placed in a bag. One slip is selected at random from the bag. Let's first determine the probability that the slip contains the name of a finch. Remember that our formula requires that we know the number of outcomes favorable to the event and the total number of possible outcomes. Since there are 9 birds listed in our data set, the total number of possible outcomes will be 9. Therefore, I know that the denominator of my fraction will equal 9. The numerator is the number of outcomes favorable to the event. So we need to look at our data set and determine how many of the 9 birds are finches. So we have this one, and we have the house finch. And we can see then that 2 of the 9 birds listed are finches. And so the probability that the slip contains the name of a finch will be 2 out of 9. We'll now determine the probability that the slip contains the name of a bird that has a high attractiveness to cracked corn. So we want to look in the cracked corn column, and we want to note the number of birds that have a high attractiveness. So as I look down my column, I only see 1 that has a high attractiveness. And so the probability will be 1 that is favorable out of a total of 9 birds. And so the probability that we have a bird that has a high attractiveness to crack corn is 1 out of 9. We'll next determine the probability that the slip contains the name of a bird that has a low attractiveness to peanut kernels and a low attractiveness to cracked corn and a high attractiveness to black striped sunflower seeds. So let's look first at the low attractiveness to peanut kernels. So looking at my data set, the low attractiveness to peanut kernels would be this one, and the bottom 3. We also want a low attractiveness to cracked corn. So let's mark those as well. So those are the ones that have a low attractiveness to cracked corn. And we want a high attractiveness to black striped sunflower seeds. And so for a high attractiveness, we'll mark all the H's. Now, when we count the number of birds that have outcomes favorable to the events, we want to look only at the birds that are marked in all 3 columns. So the American goldfinch is one that meets all 3 criteria. The evening grosbeak meets all 3 criteria. And the northern cardinal meets all 3 criteria. And so we have 3 birds that are outcomes favorable to the event. And the total number of possible outcomes, again, is 9 because we have 9 birds listed in the data set. And so our probability will be 3 out of 9, which will reduce to 1/3. The final part of our example asks that we find the probability that the slip contains the name of a bird that has a medium attractiveness to either peanut kernels or cracked corn or both. So again, let's look first at the medium attractiveness to peanut kernels. That would be this one, and that one. And let's also mark the medium attractiveness to cracked corn. And the question says we want either peanut kernels or cracked corn or both. And so in the wording of the problem, we can see that we really only have to meet one criteria, even though it's okay if we were to meet both. And so let's count the number of birds that meet one criteria or the other. So we have 1, 2, 3, 4, 5, 6. So those 6 birds either have the attractiveness to peanut kernels or the cracked corn or both. And so we have 6 outcomes that are favorable out of 9, because there are 9 birds listed in the set. And 6 over 9 is going to reduce to 2 over 3. And so the probability will be 2/3.